sugar is added to water. Okay, if I forget to, from next time, if I forget to record the class, do let me know, okay? Because you people also need the recorded lecture. Okay, so when sugar is added to water and stirred, it dissolves quickly. It dissolves quickly. Full stop. The sugar seems to disappear. The sugar seems to disappear. The sugar seems to disappear. Yes, I will post the recording in Google Classroom, Apurva, okay? I'll post the link there. Okay, so write down, uh, when sugar is added to water and stirred, it dissolves quickly. It seems that, it seems that, it seems that sugar is, it seems that sugar has disappeared in water. It seems that sugar has disappeared in water. It seems that sugar has disappeared in water. Now, what is happening here is exactly that we will write. Now, both sugar and water are, both sugar and water are made up of small particles. Made up of small particles. These particles are very small and even cannot be observed under a microscope. So these are so tiny and so small that you cannot even observe under the microscope. Okay. So when sugar dissolves in water, they break down into small particles. They break down into small particles. These small particles occupy the spaces which is present in between the water molecules, which is present in between the water molecules. Therefore, therefore, sugar solution will taste sweet even though you cannot see the sugar particles. Okay, write down this. Done? Okay, fine.
Yes, ma'am.
Okay, so we were doing this evidence, like how we can physically observe that any matter is made up of very tiny particles. Okay, so for that evidence, we have started with this example where we are using this KMNO4 dissolving a solid in a liquid. Okay, now we will observe the mixing of two gases. Second evidence is your mixing of two gases. So first understand, then I'll dictate you. So mixing of two gases. Okay, now, so I have this kind of container. It's a very long tube-like container, okay? And it is bifurcated. Yeah, you can say that it is divided into two parts. This is your part A and this is your part B. Let's say part B is filled with a gas. This is your part B and it is filled with a gas which is known as bromine. Okay, and the color of bromine gas is actually brown in color. You can see this gas because it has the colored particles which is brown in color. All these are your particles of bromine gas. Okay, very tiny particles. Although you can't see them through your like eyes, colorless you can't see, but these brown gas you can see. So this is what bromine gas. Bromine is your Br2. I'm writing the formula also and the name also. This is your bromine gas. The short form of bromine is represented as Br. Okay, now this upper side here, this contains air. Now, air, you know that air does have a lot of gas, है ना? Gases like O2 or N2, helium, a little amount of helium, oxygen, nitrogen, some water vapors. Okay, all these are gases in nature, gaseous in nature. Okay, so air does contains um, these gases, the particles of these gases, but these are not colored. Basically, these are colorless gases. These all are your colorless gases. So that means this does contain particles or matter, but you can't see them. Now what happens if if I put a little bit of hole here at the center of this container? So what is going to happen? The gas molecules from this bromine, this B side, they will start moving and occupying the spaces in air, and the air particles will come here and start occupy the spaces in part B. So basically the concentration of air is more at A part. It is more at A part. So it is going to move from higher concentration to lower concentration. That is from part A to part B. This is for the case of air. But for the case of bromine gas, higher concentration is at B part. So what is going to happen? Again, it is going to move because this is a process of diffusion. These all matter or these gas particles, they are not stationary. They are constantly moving. So wherever they get the opportunity to move, they are going to move. So here from higher concentration bromine gas, from this higher concentration to this lower concentration, they are going to move. So at this, you have high concentration of Br2 gas, that is your bromine gas, and here you have low concentration of bromine gas. Since air is colorless, you can't see air moving. Okay, it will be difficult for you to observe the air moving. But since bromine is colorless, you can see that bromine is moving. So now again, after some time, what is going to happen? Both the parts of the container, that is your container A here and this is your container B, both will have the particles of bromine gas. Okay, like this at container A and here also at container B. Understood, everyone? Is that clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Rohit, everything is made up of atom only. Everything. Our cell, it also contains atoms. Everything
Okay,
in
ma'am.
the world is made up of atoms. Although it is a single cell, but you do have in this biology, you might have heard there is some cell wall and everything. Cell wall is made up of some chemicals, okay, and then you have the nucleus and everything जो भी होता है उसमें, वो सब भी एटम से ही बने होते हैं, everything.
Okay, ma'am.
Okay, so draw this diagram and then I will dictate you like whatever is happening here. But first draw this. So after some time from here, you will get this situation. So draw this diagram. Pratika, what is happening here in this case? Now there is no high and low concentration because this side of the container had only bromine gas and this side of the container had only air. Okay. After a few time when there is a mixing of gases taking place, now the concentration of actually the mixing of gases will take until the concentration becomes equal in both the container. Okay, that is basically known as your saturation point. Like after that, no mixing can take place because concentration has become same, and mixing will start keep on doing until and unless saturation point has come. Okay, so now below this, write down. Okay, here, write down. Air is a colorless gas. Air is a colorless gas. So actually, when you are looking at this, you are fine. It's look like it's empty, but actually it is not empty. It is filled with air. So you write down air is a colorless gas. So when a gas jar is empty, so when a gas jar is empty, it is actually filled with air. This is because air is colorless. This is because air is colorless. We cannot see it in the jar. We cannot see it in the jar. Next point, bromine gas is reddish brown in color. Bromine gas is reddish brown in color. And it is heavier than air. And it is heavier than air. Next point, after some time, after some time, the reddish brown, after some time, the reddish brown bromine gas spreads in both the jar. It spreads in both the jar, like the upper part and the lower part, A and B part both. Now, what is happening here? Exactly, I've already told you, just write down in the notes. Both air and bromine vapors, both air and bromine vapors are made up of very tiny particles. Is made up of very tiny particles. The moving particles of air as well as bromine, of air as well as bromine, collide with each other, collide with each other, and they are moving almost in all directions. Almost in all directions. And ultimately, they will get mixed. Ultimately, they will get mixed. So we can clearly see that the gas particles of bromine are moving, okay? And this is also one of the evidence that every matter is made up of very small and tiny particles. Write down this. Bromine gas is heavier, okay? Then why it is moving and getting mixed with the air? Because as compared to air, it is heavier. That means it will also have a gravitational pull. Then still it is getting mixed with the air. Why is that so? Okay, so Shivans has asked the correct question, that it is heavier and still it is moving in upward direction. So Isn't any gravitational pull is applying on these gas tiny particles? What is happening here? डिफ्यूजन तो हो ही रहा है, ऑफ कोर्स डिफ्यूजन हो रहा है, बट क्यों मूव कर रहा है? इफ इट इज हेवियर देन एयर, व्हाई इज इट मूविंग? Yes, Amrit, if you consume bromine, it is dangerous. Okay, it is quite toxic. Actually, we use bromine to kill insects and everything. If you inhale it, it will be quite toxic. Yes, yes, good Shivansh. What is happening here is, although the particles of bromine is quite heavy, I told you that this is a heavy gas as compared to air. Still, it is moving in upward direction, and there is like gravitational pull is quite negligible. The reason is that they have high kinetic energy. Okay, they have high kinetic energy. Any substance, they have a different kinds of energy, but basically you should know that any substance will have majorly two kinds of energy. One is your potential energy, and another one is your kinetic energy. Now, what is potential energy? Any object when it is at rest, okay, whatever energy it has, it is known as potential energy. Okay, and any object when it is moving, and whatever the kind of energy it has at that time is known as your kinetic energy. So for these gas molecules, when they are moving, they have quite high kinetic energy, and since their kinetic energy is high, they can move easily irrespective of the gravitational pull. Okay, अंडरस्टूड शिवान, समझ में आया? इसमें लिख लो नोट डाल के यहाँ पे, राइट डाउन हियर. Bromine gas is heavier than air. Bromine gas is heavier than air. No, it's not the property. Like it's the property of every matter, Rohit. Not only for gases. The particles present in liquids, they are also constantly moving. They are not stationary. Okay, so in this write down, bromine vapor is heavier than air. Even then, even then, it goes up and mixes with air. Even then, it goes up and mixes with air. Due to the due to the Yes, Samarth, if you heat, diffusion will occur faster. I'll tell you about all these things. Just wait, huh? Just wait for 2-3 minutes. I'll tell you all this also. Just write down first this thing. Bromine vapor is heavier than air. Even then, it goes up and mixes with air. This is because this is because particles of the gas molecules, particles of the gas molecules have enough kinetic energy, have enough kinetic energy have enough kinetic energy to overcome gravitational force. Have enough kinetic energy to overcome gravitational force.
kinetic energy after?
Bromine gas has the enough kinetic energy to overcome gravitational pull. Okay, so from this experiment, what are the two processes you come across? Okay, what are the two processes you are coming across here? Majorly two processes. The conclusion is there. यहाँ से पूरा दो एक्सपेरिमेंट जो हमने पढ़ा तो उससे कंक्लूजन निकल के आता है. फर्स्ट थिंग इज दैट द मैटर इज मेड अप ऑफ. हमने पहले स्टेटमेंट दे दिया था कि मैटर जो है स्मॉल टाइनी पार्टिकल से बन रहा है, बट विद दीज एक्सपेरिमेंट्स वी कैन कंक्लूड दैट यस इट इज ट्रू. ओके, so the matter is made up of tiny particles. This is the first conclusion. And second conclusion is your the particles are the particles of the matter are constantly moving. The particles of the matter are constantly moving. Anvita, which part you want me to repeat? I've written on the screen, no? Conclusion. Okay, fine. Write down both these 2 points. So done? Completed everyone? Let me know.
Yes, ma'am.
Yes, ma'am.
Okay, fine. So there is this third point. So we have talked about and second point was mixing of two gases, and third point will be movement of pollen grains in water. Movement of pollen grains in water. So this will tell you about the Brownian motion. So there is this small video which I got. Okay, this is pollen grains under the microscope. Okay, just give me 1 second. So you can observe that under the microscope how these pollen grains are basically moving. Okay, just a 30-second video. Particles is moving here. Okay, and those particles under the microscope, that small particles were your pollen grains. And now you are in a better position to know what pollen grains are actually. Okay, so these are some small particles which you get from the flowers. Okay, so what you can do is if you take a drop of water, okay, and this flower portion which is at the top of it, it looks something like this. Okay, and if you touch this thing on this water drop of water, the pollen grains will be transferred on the surface of this water drop. Now if you observe this water drop under the microscope, so you will observe that these pollen grains, these small particles of pollen grains, They are constantly moving. And when they are moving, of course, they will be colliding with each other. Okay, they will be colliding with each other. So this tells you about the Brownian motion. This is a very good experimental example of the Brownian motion. Yes, Varsha, suppose you are having these two particles. Okay, I have this box. Okay, and you have all these particles. If they are moving and colliding with each other, they are basically transferring some of the kinetic energy to this particular particle. This will gain some kinetic energy and it will move with a higher speed. It will collide and again collide with other particles, transfer the kinetic energy there. So this will keep on happening. Transferring of kinetic energy will keep on happening, and that is why all the particles will be constantly moving. Okay, so in this, write down movement of pollen grains in water. In this, write down the existence of Brownian motion. Carefully close the existence of movement of particles. The existence of movement of particles in liquid. The existence of movement of particles in liquids was given by was given by Robert Brown. Was given by Robert Brown. He was the scientist. Okay, was given by Robert Brown in 1827. In 1827. So he was basically a Scottish botanist. Okay, he was not chemist, he was botanist. Botanist is a subject where uh, people study about plants. Okay, they are known as botanist, and that subject is known as botany. So he was basically a Scottish botanist, and he studied about the this Brownian motion. Next point, write down Robert Brown suspended. Robert Brown suspended extremely small pollen grains. Robert Brown suspended extremely small pollen grains in water. Extremely small pollen grains in water. Full stop. On looking under the microscope, on looking under the microscope, he observed that on looking under the microscope, he observed that he observed that throughout the water, pollen grains are moving constantly throughout the water. Throughout the water in a very irregular, random motion. In a very irregular, random motion. Now, why this is happening? When these pollen grains they are present on this flower, they are not moving constantly. Okay, they are present at this tip of this flower. But the moment you put it on this surface of this drop of water, it starts moving in a random motion and shows Brownian motion. Why this is happening? Can anyone tell me what is happening here? At the tip of the flower, if it is moving, it will leave the surface also, but it's not moving constantly in a random motion in the flower. But once it gets into the water, drop of water, it starts moving randomly in any direction. Why this is happening?
Ma'am, it may be moving between the spaces in the water.
Okay, somewhat it is correct. Yes, somewhat your answer is right. Good. Okay, Shivansh, your answer is also right. You have talked in the terms of energies. That's also good. Okay, so basically, what is happening here? You have this drop of water. Okay, and of course, drop of water is itself made up of very small particles, very tiny particles. Okay, and since you have this liquid medium, they are moving constantly. So the water molecules here, they itself are moving constantly in a random motion, in a zigzag motion like this. Okay, now when you are putting these pollen grains on the surface of these water molecules, so what is going to happen? These pollen grains are being hit, or you can say that are colliding with the water molecules of these water. And once they are colliding with these molecules of water, they are gaining some energy, they are gaining some kinetic energy, so they also start moving. So this is also an evidence that already the molecules of water here, they were moving in a random motion. And since the pollen grains have come on their surface, now they have gained the energy from the water molecules. You can observe them under the size of the pollen grains, which is also an evidence that the water molecules in the water is constantly moving. Motion of the particles, although they are very small, but you can still see them. Still cracking. I think everyone is feeling this. So just leave the meeting once and join again. Anyone who is feeling that my voice is cracking, just leave the meeting and join again using the same link. Now it's okay, no? Yeah, okay. So you understood this concept, what is happening here?
Yes, ma'am.
Okay. Now write down here about this pollen grains, write down as water molecules, as water molecules. Raghavi, I am dictating whatever I taught. Okay, then again I'll explain it. Okay, just write down first. As water molecules are made up of very small moving tiny particles made up of very small moving tiny particles. So when pollen grains so when pollen grains come in contact with them, so when pollen grains come in contact with them, they are hit by the molecules of water. They are hit by the molecules of water. They are hit by the molecules of water. So they gain energy. So they gain energy and themselves start moving. Themselves start moving in a random motion. In a random motion. This shows that this shows that particles of the matter are constantly moving, which is known as Brownian motion, which is known as Brownian motion. Understood now, Raghavi? What is happening? Water molecules in this small particles of the water in a drop of water is constantly moving. So when you put the pollen grains on them, these moving particles collide with the pollen grains. Pollen grains gain some energy, kinetic energy. They also start moving and in a random motion. And this type of motion is known as Brownian motion. I hope it's clear now, Hannah. Okay, next is your Brownian motion in air. Okay, so a lot of you might have come across this phenomenon. Suppose your room is dark, okay, very less light is there, and from any corner, a small hole is there, and a lot of sunlight is coming, okay, and you see that very small these particles. You can observe these particles. Have you seen this thing? Have you observed this
Yes,
thing?
ma'am.
So what
Yes,
is
ma'am.
Yes, ma'am.
yeah, so what is happening there? These particles here, you are they stationary or they are moving?
Moving.
Mo-
So
moving.
Moving.
that is what they are actually Brownian motion. Okay, because these tiny dust particles, okay, which is present in air, which you cannot see when there is light everywhere, but when you have this kind of a system, there is a dark room and sunlight is coming from the window, in a ray of light, and all the dust particles you can see in that light. So all these are constantly motion, that is also constantly moving, and that is also an example of Brownian motion. Is that clear to everyone?
Yes,
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
Great. Now write down here under this topic Brownian motion in air. Brownian motion in air. So in this write down whenever a beam of sunlight whenever a beam of sunlight enters a room, whenever a beam of sunlight enters a room, we can see we can see tiny particles we can see tiny particles suspended in air. We can see tiny particles suspended in air which are moving which are moving constantly which are moving constantly in a random way, which are moving constantly in a random way. Now why these dust particles are moving? Like you know that you cannot see the molecules of gases because they are way too small. Okay, they are way too tiny, but dust particles you can observe. So why dust particles are moving? Although they are having this kinetic this thing, you can see them, they are getting some kinetic energy, but from where they are getting the kinetic energy? These are not gas molecules, so why they are constantly moving? Yes, good, Rohan, very good. No, Samat, not from sunlight, and Shivans, not because of the wind. No, it is because the air. Yes, Varsha, good. Raghavi is also right. Rohit is also right. Good. So, what is exactly happening here? Uh, the air has the gas molecule. Air has lot of gases, and they are constantly moving. But since they are way too small, you cannot see them. But dust particles you can see. Okay, from your through your naked eyes. You need not to use any microscope and everything. So when these gas molecules are constantly moving, they are colliding with the molecules of these dust particles. These dust particles are getting energy, and that is why they are randomly moving. Okay, so again, this is also one of the evidence you can say that for the Brownian motion. Okay, so just the next point in this write down. The tiny dust particles, the tiny dust particles move here and there. The tiny dust particles move here and there because because they are constantly hit by the because they are constantly hit by the fast moving particles of air, because they are constantly hit by the because they are constantly hit by the fast moving particles of air. So what do you understand? What conclusion can you draw from this Brownian motion? Yeah, these this movement of pollen grains in water and the movement of dust particles, what conclusion can you draw from them?
Ma'am, after fast moving particles,
Mm-hmm.
after
Okay.
fast moving particles,
Okay, apart from that, why we are studying this? What are our main motive? To understand that every matter is made up of very small tiny particles. So Brownian motion also supports this evidence. Okay, since they are particles, that is why they are colliding. अगर कुछ पार्टिकल होता ही नहीं तो कोलाइड करते क्या एक दूसरे से? कॉलिजन ही पॉसिबल नहीं था. अगर पार्टिकल्स टाइनी स्मॉल पार्टिकल से नहीं बने होते, इट वुड नॉट हैव बीन पॉसिबल that they are constantly moving. So again, this is also one of the good evidence which tells you that uh, gas particles are made up of very tiny small particles. Understood?
Yes, ma'am.
Okay. Yes, Shivansh, you can say that Brownian motion helps in sharing of kinetic. It's not sharing of kinetic energy, it's actually transferring of kinetic energy. You can't say like this sharing and everything. Okay, it's the transfer. Sometimes the whole kinetic energy is transferred, sometimes little bit. Okay, fine. So now we will be talking about some characteristics of the matter. Okay, so next topic is characteristics of the matter. First characteristics is that whatever we have concluded till now, the particles of the matter are very, very small. Second, the particles of the matter have spaces between them. Third, the particles of the matter are constantly moving. And the fourth one, the particles of the matter attract each other. So we will be dealing with all these characteristics one by one. Okay, so just write down first these characteristics. And if you're not able to understand my handwriting, do let me know. Done?
Yes, ma'am.
Okay. So first let's talk about the first one. The particles heading down low of the matter are very, very small. So let's understand this with the help of an simple experiment. Okay, suppose I have this beaker. Okay, and it's 100 ml, and I have added potassium permanganate, that is your KMnO4, which is of course pinkish and purple color. So if I am dissolving this KMnO4 in this whole liquid will be basically pink colored. Lot of it will be quite concentrated and dark color pink you can observe. Okay. Now suppose I am taking another beaker. Okay, I am having this another beaker, and in this beaker I have 90 ml water. Okay, 90 ml water, and I have added 10 ml of this solution to make it 100 ml. So total 100 ml I have here. So I will observe that the color will be a little bit lighter here in this particular solution, little bit lighter, because you have taken only 10 ml of water from the first container. So concentration of KMnO4 here will be low. Now suppose I take another container. Again it has 90 ml of water, and now I am adding 10 ml from this container. So the now concentration of KMnO4 will be still less. Okay, let's take one more container. Again I have 90 ml water and I am adding 10 ml from this. Color will be even lighter now. Very few particles will be here. So basically what we are doing, we are diluting the solution of KMnO4. Diluting means we are adding water. Whenever you add water to anything, you are diluting it. Okay. So this is a process of dilution. So in all these four containers, you can see that the color of this KMnO4, it becomes lighter and lighter. So this means that KMnO4 itself, KMnO4 itself is made up of tiny particles. And when you dissolve them in water, when you dissolve them in water, they occupy the spaces in between the water molecules that I have already told you. So even though if you have very small number of particles, let's say 4 or 5 particles of KMnO4 only, that will also give the color, pink color to the water, although it will be very lighter. Okay, so this also tells you that they are made up of very tiny particles. So they are getting diluted, very less number of particles are there, and still you can observe the color here. Okay, so though, draw this diagram. I have to take attendance also. Till then, you people just draw this diagram. Okay. Okay, so you have to attend your roll calls also. Okay. Okay. Muhil Varman.
Present,
Muhil.
ma'am.
Okay. Varun.
Present, ma'am.
Okay. Pratika.
Present, ma'am.
Sushant.
Present, ma'am.
Shreya.
Present, ma'am.
Okay. Deepa.
Present, ma'am.
Inchara. Inja is absent. Okay. Tanishka,
Present, ma'am.
Rohit,
Present, ma'am.
Ashwini,
Present, ma'am.
Raghavi.
Present, ma'am.
Okay, Varsha,
Present, ma'am.
Amrit,
Present, ma'am.
Akash, Akash is there. Akash, I'll mark you absent. Although you are in class, that means you're not listening to me. Anvita is there.
Yes, ma'am. Present, ma'am.
Okay, Rishi is absent. Jalen.
Present, ma'am.
Okay, Farhan. Farhan is absent. Amrita. Nishika.
Present, ma'am.
Sankiti.
Present, ma'am.
Ananya. Okay, Ananya is absent. Bhumika.
Present, ma'am.
Ma'am, Ananya is not there.
Ananya is not there in class. Yeah, I know. I've marked her absent only.
No, ma'am, she has not joined Avanti.
Okay, she has not joined. Okay, her name is there. Okay, fine. Then Bhumika,
Present, ma'am.
Apurva,
Present, ma'am.
Adarsh,
Present, ma'am.
okay, Nutan, okay, Nutan is absent. Rajat, Varsha,
Present, ma'am.
Safwan, Safwan is there.
Present, ma'am.
Okay, Nikhila,
Present, ma'am.
Tejas,
Present, ma'am.
Rohan,
Present, ma'am.
Samarth,
Present, ma'am.
Shivansh,
Present, ma'am.
Tanvi, okay, Sanavi is there. Gauss,
Present,
what should I pronounce you? You tell me how to pronounce your name. Huh? Pranjan?
Present, ma'am.
Okay, fine. So, okay, so today we'll end the class here only and we will continue rest in the next class. Okay, apart from that, if anyone is having any doubt in today's class, you can ask me. I hope everything is clear, okay? Just go through your notes and just ask me.
Ma'am.
Hmm. पूछो. आकाश, why you didn't give your attendance? अभी तो मैंने absent mark कर दिया, अब तो हो गया. Okay, so no doubt till here. Piyush, your name didn't came up, क्या?
No, ma'am.
Okay, it's not there. I will talk to Vishnu sir. It's not there in this LMS, okay? I'll talk to Vishnu sir, okay? He'll add you in the LMS.
Okay.
Okay. So apart from that, okay, mic problem था. चलो ठीक है, तुमको present कर देंगे. Okay, anything else? Anyone have any doubts? So let's clear it. Else I am going to end the session. Yes, I will send these.
Ma'am, will you send notes, ma'am?
Yeah, of course I'll send the notes. It will be uploaded in Google Classroom.